Hello, Business Finance 330 students, both online and remote. Welcome to week 3, the past, present, and future in finance, another way of saying the time value of money. We're talking about chapter 5 this week, present value, future value, annuities, amortization. A very important discipline and concept to use with spreadsheets in financial management. You have an assignment this week, number 1, which is covering chapters 1 through 4. That work is due this Sunday, June 26th to Blackboard. And next week you have another assignment, which will be on chapter 5, asking for practice of time value of money problems. That will be posted next Monday, June 27th, and due Sunday, July 3rd. So that's our work coming forward. Also next week, we're heading into week number 4, which means it's professor meeting time. I'll be posting this weekend a schedule to pick dates and times to meet with me individually for about 10-15 minutes over Zoom, just to make sure you're acclimated to our class at the halfway point. If you have any questions or concerns about our material, look for that this weekend and I will let you know accordingly. So let's talk about the time value of money. First of all, let's see a little video explaining it.
Hello and welcome to subjectmoney.com. In this video, we're going to do a lesson on the time value of money concepts, present value and future value. So let's go ahead and get started. What is future value? Future value is the value that a sum of money today will be worth at some point in the future if invested for a return. Suppose you have $100 today in an investment opportunity that offered you a 10% return if held in that investment for 1 year. If you were to put your money in that 10% investment vehicle and let it grow at 10%, it would be worth $110 in 1 year. This means that the future value of your $100 in 1 year is $110. Now for the future value formula. There are 3 pieces of information needed to calculate the future value. We need to know the present value, which is the amount of money today, which is represented by PV. We need to know what the interest rate or rate of return investment opportunities are offering. This will be the discount rate when finding present value. And we finally need to know how many periods the investment will be held, represented by N. When conducting this formula, you need to make sure that N and I match. In other words, if I is an annual percentage rate, then E and N, your periods, need to be years. If I is a semi-annual interest rate, then N would be 6-month periods. Let's do some examples. If we were to invest $100 at 10% for 1 year, it would grow to $110. If we were to keep that same $100 in the account and allowed it to grow an additional 10%, it would grow to $121. Now that in the first year, our investment grew $10, but in the second year, it grew $11. This is because of compounding. In the second year, not only did we earn 10% interest on our $100 investment, but we also earned 10% interest on the interest earned from the previous year. So what is present value? Present value is today's value of a future cash flow. Now just about everyone knows that $100 received today is greater than $100 received in the future. This is because of 2 main factors: investment opportunities and, of course, inflation. But what about future amounts that have a greater face value? How do we compare those future values to values today? To be able to answer these present value problems, you need 3 key pieces of information. You need to know the amount of the future cash flow being analyzed. You need to know when you will receive the cash flow to determine how many periods it will need to be discounted. And you need to know the discount rate. What is the discount rate? The discount rate is the opportunity cost that you have foregone when making a financial decision. More specifically, the discount rate is the rate of return you could have earned by an alternative investment of equal risk. Suppose you won the lottery and were offered $1 million today, or $1,050,000 1 year from today. What should you choose? If you held out for 1 more year, you could have an additional $50,000. Well, a question to ask yourself is, If I accept the lower amount of $1 million today, is there an investment opportunity that could offer me returns of $50,000 or more? Suppose you have an investment that offers a 10% return and can be withdrawn without any penalties in 1 year. Should you take $1 million today and make the investment, or should you wait 1 year and receive $1,050,000? Remember the simple future value formula? Well, one of the variables in the future value formula was the present value. All that we need to do is rearrange the future value formula and we get the formula to solve for present value. What the present value formula is doing is reversing the future value formula. Now we have all the information needed to make our analysis. We have the future value of $1,050,000. We have our discount rate of 10% and our number of periods, which is only 1 year. When we plug these into the present value equation, you can see that the present value of receiving $1,050,000 in 1 year is worth $954,545. That's $45,455 less than $1 million. With this analysis, you should choose the $1 million now, instead of the $1,050,000 in the future. Understanding how to find present value is one of the most basic and necessary mathematical concepts in finance. As you build on this understanding, you will be able to figure out the present value of multiple cash flows received from investments that make more than one single payment. Understanding this concept will help you price bonds, stocks, projects, and any other type of investment that requires both cash inflows and cash outflows. Thanks for watching this video. Be sure to visit our website at subjectmoney.com and bookmark us. Also, be sure to subscribe.
Okay, a decent video describing the definitions of present and future value, but as far as the formulas are concerned, that's a good video explaining the formulas, but we're going to be doing these calculations with spreadsheets, calculating out instead of a calculator using a spreadsheet. Also, could that gentleman's voice be any more boring in that video? I was falling asleep after 5 minutes. Welcome to the world of time value of money. But here we have a spreadsheet that I've posted to Blackboard this week in our in-class review or lecture notes, and it explains the concepts a lot about what that video was talking about, giving examples of future value calculations, present value calculations of cash flow into the future, and amortization, all key concepts in the time value of money. As the gentleman said, there's 3 key things you need to know when you're talking about the value of money, either in the present or the future. The principal amount, the dollars invested, the interest amount, growth of interest during the period of time, and the time periods. How many periods? 1 year, 10 years, 4 quarters, 12 months, whatever. Need to know those 3 things. Here's an example from chapter 5. Let's say, again, I have $100 and I can invest that at 8%, compounded annually for 10 years or 20 years. What is the future value of that $100? So I can go to my formulas in my spreadsheet, both Apple numbers, Google Docs, Excel, formulas, function. I go to financial function and bring up and look for FV, future value. There it is right there, future value. Bring that up and all I do is type in my interest rate, 8%, for the number of periods, in this case, 10 years, and there's no payment, it's a present value. So if I have $100 now, I type in minus 100, meaning I'm investing $100. And that $100 invested at 8% every year for 10 years will come to $215.89. That's the future value of that. Well, if I do that same calculation for 20 years, naturally, if I wait longer and invest it longer, hopefully, naturally, I should get more money. Formula, function, financial, future value. And I want you to practice these on your own if you can. Again, 8%. Again, now the period's not 10, but 20 years. and still the present value is $100. You would use the payment line if you're making a series of payments over a time period. But for a one-time investment, you just use the present value section. And that equals $466.10. So naturally, the long, simple, common investment definition, you hold the money longer, you're going to make more money. All right, but let's take a look at this. What happens if we can only get 4% on our money? Well, again, we have $100, function, financial, future value. Now it's, instead of 8%, it's 4% for 10 periods. $100. And naturally, we're going to get less, $148.02. We now do that for 20 periods. I can just slide that formula over and now put in 20 periods instead of 10. Oops, I just did that the wrong way. Excuse me, let's fix that. There we go. And now we'll make that 20 for 4%. And we'll have $219.11. So again, we can calculate the future value of money knowing the principal amount, $100, the interest rate, either 8 or 4%, and the time period, in this case, be it 10 or 20 years. That's the future value. So I'd like you to practice these and get used to them using a spreadsheet. Why? Because we're going to be doing similar formulas and similar work using these formulas and later work in our class. What's the present value calculation look like? Well, we saw the formula in that gentleman's video, but let's do it in using our function codes, our formula codes. So let's take $215.89 and go back in time to what is the present value of that today? What's the present value of $215.89? Let's get rid of this. That's a little confusing. So let's take $215.89. And what is the present value of that? Well, hopefully it'll be $100 if we do this correctly, but let's just show how we would do that. What's the present value? So again, formula, function, financial, and now we look for PV, present value. And now we put in, again, the rate, in this case, 8%. Number of periods is 10. And now under future value, we put in minus $215.89. That's the future value that we're trying to determine the present value. Hit OK, and there it is, $100. That's the present value of $215.89, discounted at 8%, back to 10 years. That's the present value. Let's do it one more time for 4% for 20 years. Again, the amount is $219.11. So let's just try that. Formula, function, financial, present value. Now it's 4% as the rate, and that's now it's called the discount rate. The number of periods is 20, and the future value is $219.11. And we get $100 again. So either going forward in time or backward in time, that's a very important concept to be able to figure out for finance. We're going to practice this in our quiz number 2 of next week, doing these sample problems. Now, in this case, as we were talking about, this is only one sum of money, $100, turning it into these amounts, or these amounts, turning them back to $100. One payment. Well, what happens if we have a series of cash flows going out into the future? How do we determine the present value of that money? All right. Again, we're getting now over a 3-year period we're getting $200 at the end of year 1, $400 at the end of year 2, and $300 at the end of year 3. So that's $900 getting it into the future. Well, what is that money worth to now? With an interest rate or an opportunity cost of 4%. That's the cost of capital, the discount rate. Let's say we're investing $700 today to generate this $900. Now on paper, it looks like, oh, we're making $200. We're generating, we're paying out $700, but we're generating $900. But that's over 3 years. And now it's also in a market or a cost of 4%. What is its true value? Well, we can do it 2 ways. We can do it exactly how we did it here in present value, taking the $200, formula, function, financial, present value. The interest rate or the discount rate is 4%. The number of periods for this first one is 1 year, and the future value is $200 minus 200. The reason why I put minus, if I didn't put the minus sign, it would come back looking like a negative, a parentheses. To avoid that confusion, we type in minus $200. So we get the present value of that money is $192.31. Now we do the second year. Financial formulas, function, financial, present value. $4%. Now for 2 periods, this is the second year, and the future value in this case is $400. That present value is $369.82. And then we do the third year. Formula, function, financial, present value, 4%. 3 periods now, going out 3 years. Future value is minus 300. And we get 828.83 or 266.70. That totals to $828.83. On an investment of 700, it means we're making a net present value of 128.83. Now, another way of doing this calculation is determining the discounted cash flow. Same number, same way of doing it, but in one easy step. Instead of doing 1, 2, 3, if you're 3 different formulas, 3 different calculations, what happens if this project goes out 20 years? You'll be going nuts. So why don't I do this? Why don't I take a formula like this? Formula, function, financial, and look for the function NPV, net present value. Net present value. This allows me to put in all the years at once if the discount rate stays the same. So that's 4%. And then the value here would be the 3 years. So I just go to my 3 years, 1, 2, 3, and just paint it. D25 to D27. So now it's telling it to do that calculation that we did year by year in one function. I hit OK, and look what I get, 828.83, the same amount. I'm just doing it in one nice, neat little calculation using the NPV function. Here, I have to do it year by year by year using the PV function. So to note, if you're doing cash flows going out in the future and the interest rate or the discount rate stays the same every period, why don't you do the NPV function in your spreadsheet to make that a lot quicker to do the calculation? So that's the present value. Present value, future present value of a cash flow. Sometimes it's called annuities, because you get a series of cash flows. That's an annuity. The present value of a single lump payment, and the future value of a single lump payment. The last thing I want to talk about is called amortization. One of the main functions of us, in other words, you and me, to go out and borrow money for a car or a mortgage or whatever, is to avoid, to get the loan from a bank or a credit union with very little risk to the bank or the credit union. How do they get rid of that risk to them? They make us make what is called an amortized loan. a series of payments where principal and interest is being paid at every payment. Whereas bonds are non-amortized loans because the maturity, the loan is due back at the maturity date. Between the date of issuance and the date of maturity, you're just paying interest. Why? Because the lending agency trusts the company they're lending money to because they have significant assets for collateral. You and me don't have the assets for collateral. So we have to make principal payments in addition. It's called an amortized loan. Now, I'm not going to ask you to do this calculation in our class, but I want to just show you how these mortgages and auto loans that we get, how they're calculated, because it's the time value of money and using these concepts. Let's say I want to buy a car for $40,000. Kind of difficult these days. And I'm going to put down a down payment of $2,000. So I'm going to finance $38,000, and I want to finance it over 4 years, 48 months. I'm going to make 48 payments over 4 years. I run my Fico score, and my Fico score is 650. Everybody know what the Fico score is? It's your credit rating. So at a 650 Fico score, I can get a loan of 3.5%. Not bad. So I can borrow this $38,000 and pay it back over 4 years every month. That's 48 payments with an interest rate annually at 3.5%. What is going to be my payment on this loan? Well, two things I need to do. First of all, I know how many periods there are, 48. I know how much I'm borrowing, 38,000. But what is the interest rate per period? What is the interest rate per period? Well, remember, this is a 3.5% loan. That's the annual interest rate. So I have to calculate how much is that interest every month. So I take 0.035, that's 3.5%, divided by 12 months. And this is my interest rate per month. Basically 0.291%, 0.00291, and so on. So now I can go to my formulas, function, financial, and look for the function called payment, PMT. And this will calculate my loan payment for every month for 48 months. Payment, PMT. This is what they do at the credit unions, at banks, at car agencies where you borrow money from a car company. This is how they do it. Interest rate is the interest rate per period. So now you just type in 0.002916667. There's my interest rate per period. Over how many periods? Well, there's 4 years, 12 months a year, 48 periods. I'm borrowing 38,000 minus $38,000. That's the present value of the loan. What is my monthly payment? That's what's so neat about these spreadsheets. It'll tell you that my payment has to be $849.53 every year. Every year, $849.53, or every month, excuse me. So my first payment is going to be $849.53, and the interest is going to be that $38,000 balance times 0.002916667. So the interest portion of that payment is going to be $110.83. I'm taking the first outstanding balance times that interest rate per month. So it's going to be $110.83. So the principal amount of my payment, the very first payment on this car loan of $849.53, is going to be subtract out the interest. That's the principal payment of my loan. So that means at the end of the first month, if I send my payment to the bank or the credit union of $849.53, my balance at the end of that first payment is $37,261.31, the principal from the outstanding balance. So now what I do is I now bring that balance down to here. I make this the same. There's my payment. And now I'm going to take now this balance times the same interest rate, 0.002916667. There, notice how my interest goes down because why? I don't owe as much. Now this will now turn to, that's the principal portion. And this now will be my ending balance of the loan. So now that I have those first two payments done, all I need to do now is just drag this line all the way down to 48 payments. And now it copies it, and look at this. At the end of the 48th payment, I owe zero. I've made $38,000 in principal payments. I've paid $2,777.35 of interest, and $849.53 times 48 months is $40,777.35. This is how they figure out your car loan payment schedules and how you know the outstanding balance at the end of every payment. Pretty cool. Good thing to know. But it's the present value of money. It's taking this calculation of a loan of $38,000 and determining, isolating it into a payment schedule where you can now isolate interest and principal and determine your loan calculations. Pretty good. And it all works out because why? It's a zero balance at the end of these calculations. So again, I'm not going to ask you to do these calculations, but I thought it's important for all finance students and business students to kind of understand what they mean when somebody says, hey, you're getting an amortized loan. What does that mean? We're getting a series of the same payments every month on an outstanding loan where the interest and the principal are changing at the end of every payment. A non-amortized loan is a bond where interest-only payments are made until the maturity date, and then the principal is due. So there's 4 key concepts of the time value of money talked about in chapter 4, and which you need to know for assignment number 2 next week. And I'm going to save this and post it back to Blackboard to use it as a study guide in my lecture notes. So as we conclude this week 3 business finance for both online students and remote students, here's where we stand. Please make sure you always go to Blackboard to see what's going on. Whenever I send an email to you for announcements, there it is in course announcements. If you get lost about our schedule and what's going on, it's under the course syllabus schedule and information folder. Here's our 2 assignments we're talking about this week. And also, some students have yet to adjust it or see my notes on their portfolio work, and you're stuck with a 50% grade for that work. Make sure you adjust your portfolio per my suggestions in your discussion forum so you can get some of that grade back by completing your portfolio for our class. Very important. Some of you still need to do that. Here's our Zoom and YouTube links of every video posted for this class. Here's the discussion forum, which has now been updated to week 3 if you have any questions or concerns. Here's assignment number 1, due this Sunday. You need to do all your work in these files and post it, or some students will use Excel if you like, but just make sure you include all your files when you're submitting them by Sunday. Assignment number 2 will be posted next Monday. And then here's our work for this week, assignment 3, time value of money. There's our agenda, as we saw at the beginning of our class. There it is right there. Here's the spreadsheet notes that I just did. Here's an explanation of our chapters taken from the textbook, and some additional videos if you want to have additional review of the time value of money. Remember, these review problems are just for practice. And check, we just did three of these review problems in our spreadsheet tonight. So that's our work for this week. Assignment number 1 is due. Time value of money is your study. And I will put together a weekend video this coming weekend to highlight all this and also review and get prepared for assignment number 2 next week. If you have any questions or concerns, please let me know. One note for our remote class that meets every Wednesday evening. There'll be no class this Wednesday evening. I will have this lecture video is sufficing for that class this Wednesday. So no class on Zoom this Wednesday, remote students, which there's only 2 of you. So please go ahead and do that. Note that. No class this Wednesday. Look at this video. The online folks, this is what you need to do for this week. Thanks, everybody. Have a great week, and we'll see you this weekend in my update video. And if you need anything, you know where to find me. Have a great week. Adios.